The impulse momentum theorem is an equation. F times delta t is equal to m times delta v. This left portion of the equation is called the impulse. And the impulse is a net force multiplied by the time over which it acts. An impulse will change the object's momentum. The impulse is equal to the change in momentum. That's the impulse momentum theorem. Now this theorem, this equation, is really nothing more than Newton's second law. Newton's second law said a net force is equal to a mass times an acceleration. Well, an acceleration by definition is the change in velocity over change in time. So if I take this delta t and move it on to the other side of the equation next to the f, you can see that I get the impulse momentum theorem. We can see then from the impulse momentum theorem that if we want to maximize the change in momentum, that is, if we want to make the right side of this equation as large as we possibly can, we do that by imparting as large a force as we can over the longest possible time we can. This is why athletes swing a golf club or a tennis racket or a baseball bat pretty hard. That makes this F pretty large. And a golfer or a tennis player or a baseball player will follow through in order to maximize this time aspect. In other words, by following through, the amount of time that the ball is in contact with whatever's hitting it is maximized. So if you swing very hard and follow through, that will make both of these terms, F and delta t, rather large, and that will make the change in momentum of the ball be a maximum. On the previous slide, we talked about how to maximize the change in momentum, and we did that by maximizing the force and, where possible, maximizing the time. Now let's look at another side of the coin. Let's say that we have a known change in momentum. This trapeze artist, for example, has a certain mass, and if the trapeze artist misses the handhold, she's going to fall, and she's going to go down and down and down, and she'll have a certain velocity before she starts to slow down. And at some point, she's going to come to rest. So she has a certain mass, and right before she starts to slow down, she will have a certain velocity, and then she will come to rest, and so we will also know the delta v. So we know the right side of this equation. Here's where the impulse momentum theorem comes in. This trapeze artist can be brought to rest using a very large force exerted over a rather small time, or this trapeze artist can come to rest by having a rather small force exerted on her over a rather large time. And clearly, the trapeze artist would rather have a smaller force acting for a longer time than a larger force acting for a tiny amount of time. This is why we have safety nets, because safety nets increase the amount of time which it's going to take this trapeze artist to come to rest. If we didn't have safety nets, then the trapeze artist would hit a very hard floor, and the amount of time that it would take for her to come to rest would be very small, which means that the floor would exert a very large force. The same thing is true with car crashes. Behind the green car, there was another one that smashed into the back of it, and that was a change in momentum for that car. That change in momentum was affected by this impulse. Remember that the force times the time is called the impulse. So, do we want a large force acting over a rather small time, or would we rather have a relatively small force exerted over a large time? Safety-wise, we would rather have a smaller average force exerted over a bigger time. This is why car manufacturers make cars crumple whenever they get into accidents, because by crumpling, that increases the time and thereby minimizes the force and therefore is safer for the passengers. Same thing with boxers. When someone like Mike Tyson throws a punch, there is a certain momentum that has to be taken care of, and it's usually taken care of by the other boxer's face. That other boxer has a choice. Would I rather dissipate or take care of that momentum with a large force over a small time, or a smaller force over a larger time? And the answer is a smaller force over a larger time. This is why boxers roll with the punch. When they see the punch coming, they'll roll back. That increases the delta T term and thereby minimizes the F term. Same thing with an egg tossing contest. You know that when you catch the egg that's tossed to you, you start catching it and you make it come to rest in the maximum amount of time. You maximize the time, thereby minimizing the force. And if you do it right, that force is small enough that the egg won't crack. Final thoughts on the impulse momentum theorem 1. First, the impulse momentum theorem says that a net force applied to an object over a certain time interval will change the momentum of the object. It is a restatement of Newton's second law. A better name might be the impulse change in momentum theorem. Second, for a given change in momentum, a large time interval means a smaller net force. A tiny time interval means a larger net force.